Hello guys, it's a video of all formulas of engineering mechanics which is help you to crack GATE as well as engineering services exam. So all the formulas are available in this video from engineering mechanics. Welcome to Jobs and Education. Do subscribe and share. This is your Mahesh Dole. This is the GATE syllabus. We'll see each topic with a formula. So the first topic is engineering mechanics, free body diagrams and equilibrium. And second one is friction and its applications, including rolling friction, belt, pulley, brakes, clutches, screw jack, wedge and vehicles, etc. Third topic is trusses and frames and virtual work. Next topic is kinematics and dynamics of rigid bodies in plane motion. Next one is impulse and momentum and energy formulations and the Lagrange's equation. So these are the topics which are included in GATE syllabus. The first one is free body diagrams. So that downwards gravitational force will act, upwards normal force will act. If right side the force applied and the left hand side friction will be generated. So if you take any object or body, if the body is in moving to the right hand side direction, so at the bottom surface in the left hand side direction friction will generate. So the upwards motion is nothing but normal force and the downwards force is nothing but gravitational force. These are the equilibrium equations. Sum of f of x is 0, sum of f of y also 0, sum of m also 0. So these are the equilibrium equations. Based on this you might get an MCQ. Friction. The friction formula is F equals to mu into N, where F is frictional force, its units is Newton, and N is normal force. Normal force units also Newton. So N is the normal force. In normal case N is mg, but in inclined case it is mg cos theta. If you see the figure here, if the body is on inclined surface, so its normal force is mg cos theta. Mu is the coefficient of friction, it's a dimensionless number. So friction formula is F equals to mu into N. So F is the friction force, N is the normal force and mu is the coefficient of friction. Next is speed ratio. Speed ratio formula is d1 n1 equals to d2 n2. It means d1 into n1 equals to d2 into n2. What is d1 d2? d1 d2 are the diameters of the driver and driven pulleys. If you take pulleys like this, or if you take pulleys like this, so the D1 and D2 are the diameters of the driver and driven pulleys. N1 N2 are the rotational speeds. N1 and N2 are the speeds. So they are the rotational speeds. They are in revolutions per minute, RPM. Length of the open belt drive. This is the formula. L equals to 2C plus pi of D plus D, capital D plus small d, plus capital D minus small d whole square divided by 4C. Where C is the distance between two centers. From here to here it is C. Capital D is the diameter of the larger pulley. Small d is the diameter of the smaller pulley. So this is an important formula. Length of the cross belt formula is this. L equals to 2C plus pi of capital D plus small d plus capital D plus small d whole square by 4C. So what is D here? Capital D is the diameter of larger pulley, small d is the diameter of the smaller pulley, C is the center of the two pulleys. So this is the length of the cross belt. In cross belt we are getting plus, in the open belt we are getting minus. Try to remember. Next is screw jack. So screw jack is an important topic in mechanics because screw jack has so many applications. In the screw jack, the effort required to lift a load, the formula is this one, P equals to W into tan of phi plus alpha. Because its threads are in triangular shape. So we can take its angle. Phi is the angle of this thread, and alpha, phi, two angles are there. So P is the effort applied, W is the load lifted, mu is the coefficient of friction, and where phi is the friction angle and alpha is the helix angle. So here we are getting helix, right? So the thread is like helix. So if you take one helix, so its helix angle is alpha, and phi is the friction angle, mu is the coefficient of friction, W is the load lifted, P is the effort applied. So effort required to lift a load, the formula is P equals to W into tan phi plus alpha. Next formula, effort required to lower a load in screw jack. Just now we have seen that effort required to lift the load. Here effort required to lower the load. So that is P equals to W tan phi minus alpha, where P is effort applied, phi is the friction angle, and alpha is the helix angle. So efficiency of screw jack is calculated with the help of mechanical advantage upon velocity ratio, where mechanical advantage is load lifted by effort applied, where velocity ratio is distance moved by effort upon distance moved by load. So this is very important. So efficiency is calculated by mechanical advantage by velocity ratio, as mechanical advantage is the output and velocity ratio is the input. So mechanical advantage equals to load lifted upon effort applied. Velocity ratio is distance moved by effort upon distance moved by load. Very important. Here we can see that velocity ratio of screw jack is 2 pi r divided by P. So 2 pi r by P is the velocity ratio. Mechanical advantage of screw jack is 2 pi r n by L. 2 pi r n divided by L. This is the mechanical advantage of screw jack. If we take these two and substitute in the formula of efficiency, that is equals to mechanical advantage by velocity ratio, then we'll get actual efficiency of screw jack. Next, trusses and frames. In trusses and frames, the first formula is for perfect frame. So its formula is M equals to 2j minus 3, where M is the number of members, J is the number of joints. In this picture you can see so many members are there, so many joints are there. So M is the number of members, J is the number of joints. So M equals to 2j minus 3 is the equation for perfect frame. Next, simple truss. Simple truss, the formula is M equals to 2j minus 3. 2j minus 3. Statically determinate truss, M plus 3 equals to 2j. Statically indeterminate truss, that is M plus 3 is greater than 2j. M plus 3 greater than 2j. And next, unstable truss, that is M plus 3 less than 2j. M plus 3 is less than 2j. Planar truss is 2n equals to M plus r. Planar truss 2n equals to M plus r. Where space truss is 3n equals to M plus r. So these are some of the important formulas from trusses and frames. Try to remember each one. Next, kinematics of rigid bodies. In kinematics of rigid bodies, first see the rotational motion. In rotational motion, what is angular displacement? That is theta. Theta equals to theta naught plus omega naught into t plus half at square. We know S equals to ut plus half at square, right? So S equals to ut plus half at square, that is second equation of motion. So based on that we have angular displacement theta equals to theta naught plus omega naught t plus half at square. In that way angular velocity, that is omega. So omega equals to omega naught plus at. So we have first equation of motion, u equals to v plus at, v equals to u plus at. Do you remember? V equals to u plus at is the first equation of motion. So based on that we have omega equals to omega naught plus at. Then angular acceleration. Angular acceleration is alpha. Alpha equals to omega minus omega naught divided by t. So omega minus omega naught upon T is the angular acceleration, and relationship between linear and angular velocity, that is V equals to omega r. V equals to omega r. Relationship between linear and angular acceleration, A equals to alpha into r. So all the details given here. Omega is the angular velocity in radians per second. Alpha is the angular acceleration in radians per second square. V is the linear velocity in meter per second. A is the linear acceleration in meter per second square. R is the distance from the axis of rotation to the point of interest, and T is time in seconds. These are important formulas. We have plane motion also. Just now we seen that rotational motion. In plane motion, velocity of a point on a rigid body, velocity equals to V naught plus omega into r. Acceleration of a point on a rigid body is A equals to A naught plus alpha into r plus omega into r. So these are the formulas for plane motion. Next, impulse. Impulse is nothing but force into time. This is force into time. Its symbol is J equals to F into delta T. So J is nothing but impulse, F is the average force, and delta T is the time interval over which the force acts. So time is in seconds, force is in Newton, and impulse is in Newton second, NS. Newton second is the unit for impulse. Momentum equals to mass into velocity. So its units are kilogram meter per second. Kg meter per second is the unit for momentum. So mass into velocity is the momentum. Its units are, we know mass equals to kg and velocity equals to meter per second. So kg meter per second is the unit for momentum. Next, energy. In energy, the first one is kinetic energy. We know that kinetic energy is half into mv square, where mv is the mass of the object, v is the velocity of the object. Potential energy equals to m into g into h. So m is the mass of the object in kg, and g is the acceleration due to gravity, meter per second square. H is the height of the object in meters. Next, mechanical energy. It is the summation of kinetic energy and potential energy. Potential energy, this is nothing but half into k into x square. So half into k into x square. So k is the spring constant, x is the displacement from the equilibrium position. So kx square, half kx square is the elastic potential energy, very important. Next, Lagrange's equation. So it is d by dt of delta L by delta qi bar minus delta L by delta qi, that is equals to 0. So what is this qi? The ith generalized coordinate of the system, qi. So qi bar is the time derivative of the ith generalized coordinate. So this is Lagrange's equation, very important, try to remember. And what is the centroid of a triangle? So centroid of a triangle, we can take it as x bar equals to x1 plus x2 plus x3 by 3. If we have 3 vertices, triangle means 3, right? So x1 y1 plus x2 y2 plus x3 y3. So x1 plus x2 plus x3 by 3 is the x bar, and y bar is y1 plus y2 plus y3 divided by 3. This is the centroid of triangle. What is the centroid of rectangle? So in x case, x bar is a by 2, in y bar is b by 2. This is the centroid formula for rectangle. Next, centroid of square, x bar is a by 2, y bar is a by 2. So both are same because of square, from every side it is same. Circle, the centroid of the circle is exactly at the center. The center point is the centroid of the circle. Centroid of the semicircle is 4r divided by 3 pi. So 4r by 3 pi is the centroid of the semicircle. Centroid of general shape. So if any general or complex shapes are there, its x bar is integration of x dA by a, y bar is integration of y dA a, where x and y are the coordinates of the centroid. dA is the infinitesimal area element, a is the total area of the shape. So this is the generalized shape centroid formula, very important. Do share and like and subscribe to my YouTube channel. This is Mahesh Dole signing off.